We believe on Jensen and NVIDIA. When they have a new technology, they always have good technology. And that's another reason why we are able to deliver product earlier than others.
So, hello Charles, thank you for inviting me to your factory where we have all these beautiful servers behind us. But we want to talk about sort of how you got here, right? And all the building blocks of what you produce today. And I think it'll be amazing to walk through that story with you because it's not been told too much.
Yes.
The history of Supermicro, which started out quite small, but now is one of the largest server companies in the world, and not just servers, but really for the data center and AI infrastructure space as a whole.
Yes.
So how you got here and such will be a great story to tell.
Thank you, Dylan. Nice to meet you, and happy to share our story. Yeah, Supermicro started from very small Silicon Valley, 3-person company.
Yeah.
And today, after 32 years, we have about 7,000 employees worldwide, about 4,000 in Silicon Valley.
It was quite odd that you founded it then, right? At that time, most companies were outsourcing everything to Asia, moving headquarters. Companies were falling in Silicon Valley. Silicon Valley was no longer Silicon Valley, right?
Yeah.
No one makes fabs here. No one makes chips, right? No one makes servers. It's very unique that you decided, hey, actually, let's make a factory here. Let's start producing in Silicon Valley. That's so different than what was happening at the time, right? Because at the time, everyone was going to all the OEMs and ODMs in Asia, and they were removing everything they were doing in the U.S.
Yeah, it's a long story. When I come to Bay Area, 1988, right? So I start design computer system, and then later I design a chip. And then later, I heard everyone, especially my company, ask me, design something cheaper. And then I think, hey, why I come to Bay Area? I come to Bay Area from Taiwan many years ago, and the goal is to design something better. That's why I say, hey, can I design something better? And that's why I founded the company here in Silicon Valley. And because Silicon Valley, as you know, everything is more expensive. And at that time, I was a very dedicated engineer. I did not study the market that much. I thought, hey, I'm an engineer, and I believe we should design something better. So I founded a company, and after I founded a company, I figured out very soon, hey, Silicon Valley is so expensive. It's not a best place to design and manufacture computer hardware. But I already founded a company, so I want to make it successful. So the idea came to my mind, hey, at least I can design something better, especially something better in terms of performance per dollars.
Yeah.
I remember at that time, 1994, a PC magazine reviewed the high performance PC company in USA. And around the review, about 30% of the company use my motherboard, use our product. And that's a very exciting experience. At that time, Supermicro was about 10 employee company. And there are 30% of company use our product.
What was your first product? It was a motherboard. Was it Intel CPU? What was it? It was a PC motherboard, server motherboard. What did you make?
Yes, it's a Intel CPU motherboard. And we are able to design a product and make them available earlier than others. Although we were a 10% company, but because our product outperform others, that's why lots of people want to buy from us. And indeed, at that time, our production capacity was very limited because everything designed in the USA, manufactured in Silicon Valley, and we are a small company, so the volume capacity was limited. But lots of customers want, so people pay us COD, pay cash when delivery. And some customers even say, well, if we pay in advance, can we have a higher priority for allocation? And our sales guy told them, yes, if you pay COD, cash in advance, you have a higher priority. So we start business like that.
That's funny because this is always a challenging thing today, right? Is is it net 30? Is it net 60? How long until you get paid, right? But you took it the other way around. No, you pay me before I even send it to you. So this is it's unique.
Yes, I like that time frame.
Couldn't work that way forever, unfortunately.
I guess it's not easy now.
Yeah.
Yeah.
You came to Silicon Valley, but before that, you were actually in Texas, right? What was Texas like? What were you doing in Texas?
I studied in Texas.
Yeah.
For my AI dream. Indeed, I came to United States in 1996 with a dream to design medical expert system. That was the incentive for me to come to United States. Medical expert
And
system.
you ended up doing chips. Tell me more. Or not chips, but data centers, hardware, server hardware. But tell me more.
Sometimes we had to face to the reality, right? And at that time, not many people really focus on medical expert system. And then at that time, it's a PC boom time frame. So that's why I say, hey, if I cannot design medical expert system, then at least I can design PC. And that's why I want to design a based computer system. Start from that time frame.
PCs are one thing, but then you started moving into other parts of the computing industry.
Yeah.
I heard there's ATMs all around the world with Supermicro systems that were built in the 90s. Can you talk a bit about the ATM systems? This is so different than PC. Okay. It's a server, right? It's basically a server, but it's the most durable server in the world. Can you tell me about this?
It was a long time ago. I had to think about it. The ATM machine, yes, I guess it happened in 1995, I guess, when Supermicro was still very small. And there's a very smart engineer come from Citibank. They visited me and said, Charles, we have ATM machine coming soon. And we had to pick up the best motherboard for our ATM system. ATM system working from Alaska to Arizona in summer, and it's outdoor, so the machine had to be very robust, can work in very low temperature, very high temperature, and had to be very reliable. So they have a support from IBM and from Intel. At that time, Intel designed very good motherboard. And then they said they need 3 to select from, and I'm the third one. So that's why they visited me. And I'm very happy to introduce. And then they bought, I remember, 50 systems to test, to burn in for 3 months. After 3 months, there's a very early morning. Guy called me, said, Charles, congratulations. I said, what? He said, you won the deal. I said, how can I win the deal? He said, because your product is the best. So from that moment, again, further confidence. Hey, if you work hard, work smart, we can design a best product. I remember at that time, we are still a small company, about 10 to 15 people. But our product turned out the most reliable system that passed their validation, their burn-in.
That's funny because I'm not sure if the listeners at home can hear, but we're sitting right next to the burn-in room, right?
Yeah.
That Supermicro has, right? It's not the customer doing the burn-in; it's Supermicro doing the burn-in, and you can hear all the fans and liquid cooling and all these things. I don't know if it's the whispers in the background, but it's quite amazing. The customer did the burn-in and was like, "You're the best." Now you're like, you guarantee your products. You're like, "Hey, I'm doing the burn-in myself, and it's the best." So I think it's an interesting change.
Yeah, it happened, for example, the ATM machine happened in 1995 when we are very small and we have a basic product. So we try to keep it a record until now, until future. Right? So that's one of Supermicro DNA now. We like to design a basic product.
With the burn-ins, right? How long are you doing this now, right? How long are you doing your burn-ins for the servers all behind us, right? That are about to go to some customers.
The sounds to some people may be very noisy, very annoying. To me, it's very nice music because we go to our company because of those burn-in. I remember I personally designed the burn-in device since 1994, how to burning your system through very low temperature, very high temperature, and all the dynamic change, and make sure the system all went through those process, and make sure the system are mostly reliable at the customer side. So from that moment to now, we continue to improve our system, continue to improve our process, and that's why today I believe we have one of the best burning system in the world, including now we had to cool down a rack at 150 kW. We have a very good burning system, low temperature, high temperature, and this story, this technology start from 1994. That consume lots of energy power,
Yeah.
for sure. But it's a good investment because when the system, when the rack, when the cluster went through that process, the guarantee when we deliver it in customer side, you plug and play. You plug in the power cable, the data cable, and now including also the liquid cable, and the system is ready to run.
Yeah, this is important because in the past, right, you would just sell a motherboard, right?
Yeah.
But as time passed on, you add more and more and more to have the complete system. Each of these system pieces, even if you test them individually, when you put it together, it might not work, right? It's not like your suppliers aren't testing it, but when you put it all together, something might not work, and you have to be able to find that.
The story started from many 32 years ago, right? So first I designed a motherboard, and then customer say, well, you have the very good motherboard, but we need the whole system very optimized. And then we try to search the best chassis enclosure, the power supply, the thermal solution for customer. But it's not easy because after we search again and again, we can make a system work, but not the best. So customers say, hey, can you further help? I say, why not? We are engineering company. We can help you. So that's why we start to design our own chassis enclosure for thermal optimization, for cost optimization, and for reliability optimization. Right? So we start to provide motherboard and then chassis. And after a while, people say, hey, how about power supply? And it's about a time frame. There's a movie called A Day After Tomorrow.
Day After Tomorrow.
Yeah, talking about the extreme weather that freeze the whole New York City, freeze
Where the whole world falls apart and everyone gets on the boats, yeah.
Yeah, and then it's given me a kind of idea. Say, hey, yes, I mean, people continue to use more and more energy, pollute our world, only Mother Earth. And how can we help something or improve something? And then quickly I calculate, hey, the power supply we use is good, is reliable, but the efficiency is not good enough. At that time, most of the power supply run at 60 to 70% efficiency.
Oh, that's very low.
Very low. And that's why I say, well, this can be a chance. Let's go to find a high efficiency power supply. So we search here around and cannot find any good one. Most of the power supply is 60%, 70%. I said, no. From our calculation, we should be able to design power supply run at least the 90% efficiency. Because, I'm electrical engineer. Right? And that's why we design our own power supply. That's about 2004.
There's the whole industry standard of like 80 plus silver, gold, platinum, titanium. That's interesting. Your goal is 90 plus.
When people talking about 80%, 85%, yes, our goal was 90%, and we meet the 90% quickly. And today we have some power supply run at a 98% high efficiency now.
Wow! And so, was it like a customer demand that required you to go to such efficiency? Or what was the reason you needed to go so high efficiency? I mean, power is important, very important for the world, very important for green. But most systems are, especially back in those days, power. I mean, it's all of computing history. Power just keeps going up. So why, who cares, right?
I guess it's a combination. From the beginning, it's the movie. My daughter remind me, Daddy, don't mention about you learn from the movie. I said, but the reality happened that way. I got that idea from the movie. So still, I mean, because as an engineer and we think about it, we design the product, and then we found that, hey, the efficiency can be 90%, can be much higher than 90%. That's why all the way we try to provide the best product to customer. When the power supply, when the system are able to run at a higher efficiency, number one, it save money for customer. And number two, it's minimize the pollution for our planet. And number three, our investment indeed was very limited. We just spend more time, design more carefully, more optimization, and then we can do it. So why not? So indeed, high efficiency design, we call green computing, start from 2004, become Supermicro's DNA. Since that time, all our design, all our product try to optimize for power efficiency.
One of the trends is power goes up and power efficiency, but another trend is more processors per system, right?
Yes.
Today, your systems, there's 72 GPUs, there's 72 NICs, there's 36 CPUs, there's all these, the systems behind us have, so many processors.
Yeah.
But Supermicro was also in the beginning the first to put two processors on a board, right? Dual socket system. Can you tell me about this? What was the industry like? Everyone was selling single socket systems. There was all the mainframes, there was all the Spark, Sun. All these systems were very big, but at the time Intel was also not the biggest company, but they were trying to get into the space, and they wanted to go dual socket, but they had challenges. Can you tell me about this?
Well, I guess you talk to our people a lot, so you know lots of our story. Yes, the first dual process system, I guess, is start from 1995 when Intel just first introduced dual process solution. I guess it's Orion chipset, and I called Intel and said, "Hey, we'd like to design your Orion solution." And I remember India told me, hey, to be friendly, your company is so small, maybe you are not capable to design that. I said, well, it's simple. Why not support me? He said, oh, we do not have enough engineering resource to support you. I said, well, maybe we don't need your engineering support. Just give me the design data book and then schematics, and we can do it. And then finally, they support us. And
so
then
they didn't believe that you could.
Because at that time we're still a small company.
Yeah.
Maybe 25 employee company.
Yeah.
Right? So after 6 weeks, we power on our system and it worked. So I call Intel, our FAE from Intel. I say, hey, our system work. He said, one CPU. I said, no, two CPU. He said, no, impossible. You don't know. I said, no, it's two CPU and working. And the Windows show two CPU. He said, no one have two CPU working at this moment. I said, mine have two CPU working. I said, you can come here to see. And they visit our office. They said, yes, two CPU. How do you make it? I said, I don't know. It's just work. Because we had to protect our IP.
so you know, but you don't want to tell.
I had to be loyal to the company. So anyway, I mean, it turned out we are the first company start to ship a dual process solution to the market. That's in 1995.
That's interesting. I think it highlights something, right? A lot of Supermicro's competitors aren't manufacturing out of the Bay, right? Bay Area. So when they have to, the chip gets sent to, from the lab of the, Silicon Valley company, whether it's NVIDIA or Intel or AMD or whoever, right? It gets shipped from there, or Broadcom, whoever it is, it gets shipped from here over to Asia. The engineers have to fly back and forth constantly. I think it's important that Supermicro does it here, right? So, hey, when they don't believe you, or there's an issue, or you want them to look at something, or you want a customer, right? When a big customer to come, they just drive 20 minutes, and it's here.
Yeah, I'm very happy to be in Silicon Valley. We are so close to all our vendor, all our technology partner, like NVIDIA, Intel, AMD, Broadcom. So when they have a good product, when they have something new, we have a chance to work with them right away closely. And then when we have any question or idea, we can communicate with them and ask for their opinion right away. At the same time, we are very close to all the major customers, right? Or a large data center or a technology leading customer. So when they have an idea, when they need some feature, we can work with them and prove right away in Silicon Valley and design here, manufacture here, brainstorm with vendor, with customer. And then that's why very quickly we can optimize the product and go for volume production. And from the beginning, we manufacture everything in Silicon Valley. So that's why the turnaround, the feedback is very fast. And now for sure, we have some offshore manufacture facility and campus. So we kind of manufacture here and manufacture also offshore.
So we talked a bit about, the first dual socket system, and today we have systems with, dozens or if not over 100 processors on them. And sort of Supermicro was the first to dual socket system. But the other challenge is thermals, right? And back in those days, everyone had single core systems. And the clock speed just kept going up and up and up and up. And the heat density kept going higher and higher and higher and higher, especially when Dennard scaling ended, right? So it really came to fruition with Pentium 4, right?
Yeah.
But even before that, Pentium 3, 2, 1, they kept getting harder and harder to cool.
Yeah.
How did you deal with that? You said you went to the chassis business, but you started doing chassis, you started doing cooling. But tell me about that progression.
Yeah, I mean, challenge is opportunity. So that has been a Supermicro culture again. When our engineers say, hey, there are some challenges, they're good, you are a lucky guy, you have challenge. So just fix the challenge, and then it will become an opportunity. Especially when we are able to deliver something better to customer, when we are able to deliver something quicker to customer, make the customer happier, that grow our business and make everyone happy. So the challenge has become a routine. First is from the beginning, right? I mean, 30 years ago, you had to design a more efficient heat sink, more optimal airflow, and more fancy air shroud, right? And then liquid cooling, right? Because liquid can cool down the system, the chip, much more efficient than air, right? So, and liquid cooling, there are lots of challenges.
So back in those days, efficiency was important.
Yeah.
Back in those days, going to multiple sockets was important, but also, and that's the same trend we see today, people stuffing more sockets into one system, right? More chips. But one of the other trends was that each chip that we see today is each chip gets hotter and hotter, right? Today, Blackwell's 1200, 1400 watts. Next generation, they go to, over 2000, right? But back in those days, chips took, 10 watts, 20 watts. And as they went over 100, what was going on in the industry? Why? How did you deal with it? How did you take that opportunity?
Okay, I mean, opportunity always come with a challenge, right? So the good thing is we are engineering company. We have many electrical engineers, thermal engineer, mechanical engineer, software engineer, right? So everyone work under the same roof. So when they are challenged, when they are opportunity, we sit down and brainstorm and say, hey, what's the best solution?
What were the challenges in those days?
For example, how to cool down the high wattage chip with most efficient mechanism, most efficient media, and then also make it cost down and make it reliable.
So today everyone's like, every time NVIDIA releases a new generation, right? From 400 watts on Ampere to 700 watts on Hopper to 1400 watts on Blackwell to over 2000 on the next generation. It wasn't NVIDIA then. What was happening? Who was your customer? Who was the one making everyone run? And how did you keep up?
Yeah, I mean, there are two ways, right? If we stick with traditional air cooler, then we just have to continue to optimize the heat sink, make a more efficient heat sink, more efficient material, and make it bigger, and airflow improvement, software management, right? And until problem fixed. And up to now, our air cooling solution can cool down a chip up to 1,000 watt or more than even 1,000 watt. I believe 1,500 watt is achievable, or even 2,000 watt. I believe will be achievable in the near future. Right. At the same time, we move to liquid cooling as well, and liquid cooling is use coolant, right, to cool down a chip, and we spend a lot of effort. We have about 200 engineers specifically focus on liquid cooling. And with liquid cooling, you save space, right? Even in 1U space, you can cool down 2,000 watt chip, CPU or especially GPU. So liquid cooling is much more efficient, and we have somewhat based technology for liquid cooling today.
So back in the beginning of the days, though, right? Beginning of the company, the 90s, people were just putting fins, heatsink fins, and that's it.
Yeah.
Not even heat pipes.
Yeah.
Not even heat pipes were being used back then.
Yeah.
No liquid, right? So how did Supermicro start adding those technologies to the portfolio? The ability to do heat pipes, the ability to do liquid cooling. When did you decide? What product was it like? Oh, we must do this.
Wow, you are talking about 20 years ago history. Yeah, so even air cooler, right? Just use cooling fan and heat sink, right? Now heat sink design can be very fancy. The fin spacing, the fin structure, and then the size and the airflow. How do you optimize the airflow? Right? We use lots of different air route. That's to direct the airflow to be mostly efficient. So far, all the thermal challenge become our opportunity, and so we are very happy to work with any partner, the vendor, the customer, to improve the thermal solution. Air cooler before, and now liquid cooler as well. Even liquid cooler, there are lots of room to be even better. So our team still every day still try to improve that.
What was the first product? What was this first necessity of liquid cooling? What was the first systems that you guys shipped with liquid cooling?
Okay. We started shipping liquid cooling since about 20 years ago. Because some customer like to save energy. And part of the reason is they are passionate to reduce the power consumption. And we are very happy to work with them since 20 years ago. And until about 3 years ago, when GPU started to consume 700 watt, 1,000 watt, NVIDIA and our team started to kind of understand, hey, liquid cooling is must be is a much better choice. So we start to dedicate a big team since about 3 years ago to optimize the liquid cooling and make liquid cooling more reliable. Never have leakage or very minimal chance of a leakage. Right? And then also make it easy for maintenance. Also make it reasonable cost. You cannot make it work, but too expensive. Right? So after 2 years, very dedicated research, study with our partner, especially NVIDIA. And then we start to deliver liquid cooling in huge volume since calendar year 24. In calendar 24, we ship almost 50% of our product with liquid cooling. And I believe in that year, just last year, I believe we ship more than 50% worldwide liquid cooling rack.
Yeah, your market share is incredibly high because you were the first to ship.
Last year, liquid cooling, I guess, at least 50%. Again, we cannot calculate in detail, but we ship a very high percentage liquid cooling.
So before liquid cooling was an option to save some power, it's now becoming mandatory. Especially if you want to maintain density, right? When we look at the systems behind us, there's 8 servers in one rack, and actually you have space for more, but maybe the data center can't provide enough power. But that's a different, story. There's 8 servers in each of these racks. This is over 100 kilowatts for the rack. It's impossible to cool that with air, right?
Yeah, because people want high density. Because in high density, the cable is shorter. And when the cable is shorter, the system, the whole rack, the whole cluster can run more reliable, faster, and minimal latency. So in this area, we appreciate NVIDIA. Their engineering team work with our engineering team very closely. And that's why we are able to deliver the really optimized rack quicker and better. Like what you mentioned, more than 100 kW. I believe 500 kW rack is coming soon. We'll ship from the same location very soon.
Kind of rewinding a little bit, back to some history. Dual socket systems you were first to, but what about the transition to dual core? Right, this time, Intel was focused on increasing clock speed so much with Pentiums, and AMD
Dual core was easy for us,
but and then AMD went to dual core, and
it's all inside a chip. So it's a chip. It's a CPU GPU company. Take care of most of the effort.
But most companies only supported one. They put all their engineering resources to the next generation. Intel always over and over. But AMD was new, and they came out with dual core first, and they took a lot of market share. But it took time even after they released the chip, right? Because systems weren't ready. It took time for people to engineer systems. How did you deal with the going from mostly working with Intel systems to now working with Intel and AMD systems?
Whoever have a good chip, whoever have a good technology, we are very happy to work with all of them. Right? We are very close to.
But it's very hard on engineering resources, right? How do you engineer for Intel, AMD, and then in NVIDIA and server systems for different accelerator companies as well, right?
Okay, somehow we are indeed also a very lucky company. Since 1993, when I founded the company, we designed all of our products based on building block solution. And that modularized building block solution helped us a lot and very powerful feature.
Well, explain.
So that with building block solution, we can support any CPU, any GPU to leverage the same modularized design. And that.
But the I/O is different, right? The amount of I/O that an NVIDIA chip or an Intel chip or an AMD chip is different. What is the building block?
You don't believe. We have more than 10,000 building block today accumulated from last 32 years. So we have lots of CPU, GPU building block solution. We have lots of I/O building block solution, lots of thermal building block solution, lots of power building block solution, and that make today's Supermicro really powerful building block solution company. So with building block solution, it helps us design product quicker than others, and help us design product better than others. Especially, we can leverage our building block to minimize our inventory, our purchasing, and even help us to support customer on-site spare parts support to make sure customers high availability with minimal cost, minimal on-site spare parts.
With the building block solution, can you sort of help me understand? Because the chip's different every year, right? Every year, NVIDIA releases a new chip. For example, on Hopper, let's say H100 when they really took off. But you were working with GPUs before this. And then sometimes the customer's like, I want AMD CPU, I want Intel CPU. And a lot of times OEM says, no, I can't do that. Or, oh, sure, that's a few months from now. How does the building block solution work? How does it help you go faster? Explain?
It's 32 years experience. So from the beginning, we will define each module, the spec, the feature, and make sure all our engineer, all our design follow the building block solution spec. So it takes time to well define everything. But after everything established, indeed the system become very powerful, very efficient.
And so for a long time you were focused only on CPU-based systems, storage systems, which Supermicro is very large in as well. But tell me about how you got really big into storage, because there was a big shift in the industry, right, from hard drives to SSDs. And I think Supermicro was very early on moving to SSD. Can you tell me about what made you realize that SSDs were important to chase, that SSD-based systems, storage systems, which at the time were less than 1% of the market, but now they're the majority of the market. What sort of did you see, and why did you do that?
Again, I would like to say we are a very lucky company as well. Other than we are working very dedicatedly and with lots of smart engineers, right? our building block solution indeed is more powerful and more lucky than what I expect from the beginning, 1993. So with our building block solution, all our building block support not just across different product line, different vertical of product, but different generation of product. So that kind of more than 10,000 building block in our company are very flexible, powerful, and very optimized for pretty much any customer's specific application or workload. We are able to optimize the solution for them in terms of quality, time to market, cost, power saving, and easy for maintenance.
So, we talked a lot about Supermicro's cooling. We talked a lot about Supermicro's power delivery. We talked about power supplies. We talked about Supermicro's multi-socket systems, right? One of the other areas, I think there's some other areas that are very important for Supermicro, and that's storage. How did
and management software
and management software for it, right? But storage is something that used to be, you put a drive in a system, whatever, move on, right? Make sure it doesn't vibrate.
Oh, okay.
But storage changed very fast today. That's not how it works, right?
Yeah.
You have many drives, you're pulling them in and out, you have storage systems, complex. But how did you get to, because storage systems was also a very difficult business, right? It was dominated by other players, and now Supermicro is big in it, especially with some of these, twin systems and all these other things. How did you get into the storage ecosystem?
Okay. Sometimes I make a joke. Say, my biggest mistake is founder a company in Silicon Valley. But at the same time, I also feel we are so lucky to found the Supermicro in Silicon Valley. Because we founded a company in Silicon Valley, and Silicon Valley is so unique and so expensive. And that's why all our product, all our design had to be exactly the most optimized one. If our product is not the most optimized one, not the early time to market, then we cannot compete because Silicon Valley is natural, right? So
if you're late, it's a commodity.
Yeah, it's a commodity, and then it's compete for price only. And when it compete with price only, our partner, our competitor in other country, low-cost country, will sure they have advantage. So that's why that becomes Supermicro's DNA. We had to design technology at an optimized way as early as possible and with customer-based interest. That's the only reason we can grow. And the history proves the decision we select company start from Silicon Valley is so lucky.
So being first is very important to Supermicro's DNA. And you were when I look at the market, especially back when SSDs entered to the market, you were very early to creating flash-based storage arrays.
I believe that first, even not the first, at least one of the first.
Yeah, because Intel was releasing SSDs, but everyone was like, "This is too expensive. This doesn't make sense. It's so expensive, and it's fast, but why do I want this?" And you built a system, and then soon web serving and social media and many other companies were buying these SSD-based systems because the performance was needed.
Yeah.
Can you tell me about that sort of?
SSD, for example, the first 2 years, 3 years, volume was very small because not many companies want to pay extra money for those super fast device. But after a while, when software become more and more sophisticated, especially when the AI boom, that everyone need a lower latency, quick performance, higher density. So for sure, SSD, those high density HBM, for example, all become a must-be feature.
So then you were able to start making storage systems as well. And I guess the last part of the puzzle, at least in terms of, or at least one of the more recent parts of the puzzle, was accelerated computing.
Yeah.
Everyone sort of accelerated computing is kind of the opposite of what happened decades ago, right? Decades ago, everyone had these different types of chips, and you had your Spark systems, and you had IBM systems, and you had all these specialized chips, Sun Microsystem stuff, like all this different stuff, and then everything became Intel x86. AMD x86, and that was it for some decades.
Yeah.
Right. But then today we have this proliferation where all these different accelerators, whether it's NVIDIA, of course, but also AMD and many other smaller companies.
Yeah.
But how did people tried to make accelerators in the meantime? But
Yeah.
what did you do to sort of be the first and earliest on accelerators with GPUs?
Number one, we work with our partner, like NVIDIA, like AMD, like Intel program, very closely. So our team and their team work very harmonically and day and night, same time zone in Silicon Valley. So that's one of the advantages. Second, I would like to appreciate our building block solution again, because our building block solution, so we are able to shape, to optimize, to fine tune our module to fit, to optimize for the new chip quickly. And that's why lots of customers select to work with us. Lots of vendors support us very well. And together, we are able to service the industry with truly application optimized or workload optimized total solution.
But so back in those days, when accelerators first started being popular, there weren't many companies offering the solution.
Yes. We pretty much the first one.
Right. So how did that come? Right. Jensen is your friend. He came to you and he said, "Help me make this system." How did that work?
What Jensen say, I forgot, but I guess he said, "Charles, he a good opportunity. Do you want to join?" And we jump in to join him. It's 2012, I remember. So we pretty much the first company deliver 2 GPU in 1U system. And at that time, for sure, GPU only consume about 200 watt. And 200 watt at that time, 200 watt plus 200 watt plus CPU, that's about 600 watt in 1U. At that time frame, that's some of the highest computing density platform. And we quickly make that product mature, ready for production. And that's why we start to enhance the partnership quickly. Start from 2006.
600 watts in 1U, and you look at GB200, I think it's like 4,000 or 5,000 watts in 1U, right?
Yes.
So very, very, very funny.
Very quick change, yeah.
So even then, putting multiple chips in one system, so they could network at high speeds without going over long distances, more reliable. There wasn't much volume, right? In those initial systems, right?
In the early time frame.
Yeah,
yes,
early time frame.
System.
So why did you keep engineering the next generation, the next generation, the next generation? What gave you conviction that actually I need to do all these very difficult things, right? Continue to increase density, continue to build all these new building blocks around cooling, and sure, you had building blocks. But most of your volume was Intel x86 CPU. It's much easier than the GPU-based system. So you had to make all the new building blocks for this GPU system, but there wasn't much volume. So why did you do it?
I guess in this area, we are a little bit similar to NVIDIA. And I'm a little bit similar to Jensen. Although they are much more successful, much bigger. But they have lots of similarity. They want to design something like this. They want to optimize the solution and make sure it's industry interrupt technology and can really help people dramatically. And we have a similar philosophy. And that's why when there are new technology, when there are new solution, that can better service customer, can better service the industry, we jump in right away. It's not just for business, but also for kind of career mission or kind of business mission. We just try to make sure we have the best for customer, for the industry.
What's the I guess the vision that customers weren't asking for GPU based systems really. Customers weren't asking for it yet. You decided to build it before they were asking for it, so that when they realized I actually need this, you were ready. But what was the vision?
It's hard to tell who come the question first. In lots of cases, it's a vendor come out the idea. For example, NVIDIA, Jensen have a new idea, new product, and then we work together and then put into the market. Right? And lots of other cases, the customer say, hey, can we have this feature? Can we have other feature or better performance? So it's kind of sophisticated partnership and kind of brainstorm. So sometimes from my vendor side, sometimes from customer side, sometimes from our own opinion, own idea. And the good thing is that everyone work together like a big family, big group, and to provide a better technology to service the world.
So early 2023, when customers started saying they need a lot of systems, what was it like here? What was Supermicro had to, right before it was growing well, but it was growing, it's like a sort of a line like this, and then AI happens and it skyrockets. So at that point of change, how did you do it so fast? What did you do? What were you thinking?
I guess to be simple, we believe on Jensen and NVIDIA because when they have a new technology, and from our experience, they always have a good technology since many years ago. Because of that belief, so we work with them, partner with them very closely, and that's another reason why we are able to deliver product earlier than others, because we make a decision quicker, and because we believe we.
How did you make the decision to ramp production so much quicker?
Because they say their product is so good, and we believe on that. So we try to be optimize the time to market opportunity for them, for ourselves, and for customers as well. Because in this industry, especially AI, people want things to be faster, to be more efficient, and that's a very strong and must be condition. And luckily, we are able to fulfill all of those features.
A lot of your competitors, they don't have. They're older companies. They weren't founded. Their founder isn't still working there. How does that help? Right? When it's a founder, the decisions get made faster. Right? How does that help?
You are right. The founder, because I know the company the most. Like myself, I know the company from day one, right? So every piece of resource, every piece of talent or challenge, for sure, the founder know very well. And that's part of the reason why the founder can make a decision quicker.
So we had AI taking off, and you start ramping production. You decide to, expand your production facilities very rapidly. You've got new manufacturing facilities in multiple places. And then I guess there were some pivotal moments sort of that had new companies forming even, right? Yeah. Companies like Elon Musk has been buying systems from you for a long time, but he and Tesla is a big customer. But then XAI, right, comes along and they order a lot of GPU systems, but they also ordered in a very unique way.
Yeah.
They wanted all these liquid cooled servers. And so there's all these photos and videos of you in Memphis, Tennessee at their facility, helping install and can you tell me about this?
Yeah, I'm very happy to work with smarter companies, smarter people. Like Elon Musk, you mentioned, I remember that conversation. I told him, say, hey, we have liquid cooling solution ready. Do you like that solution? When do you need? He said, yesterday. So we have lots of opportunity to work with partners like that. And it's a very good experience to work with people who are really smart, who are really aggressive, who want to deliver the best technology, best product to the world. And because we believe AI boom will continue, and AI boom will have a big room to grow. And that's why we do our best to enlarge our capacity. And I have one mission since a long time ago. The mission is I want to bring green computing to the whole world. I believe I made that mission about more than 10 years ago. And now we still have the greenest solution in terms of efficiency. Doesn't matter air cooler or especially liquid cooler. So that's why I believe a customer deserves the best product, not just best performance, best time to market, but best energy saving, and also easiest for maintenance. And Supermicro have all of those features today.
I think the green computing part is something that's really important because when Elon Musk made this decision, right? We talked about, because you're the founder, he's the founder, you guys move and make decisions fast. Slow companies can't make these decisions fast, and when he decided I want to build the best AI company in the world with XAI, right? He needed to build a data center. He looked around in the market, there was no data centers ready, right? So then he built his own data center, right? He bought a factory, he turned it into a data center, and he's like, the grid didn't have power for him, right? There's no connection, there's not enough power from the grid, so he started making his own power on the site. But this is important because Supermicro servers were unique, right? Everyone else's Hopper servers, H100, air-cooled. And so each server consumes, 10 kilowatts almost, right? But if you do the liquid-cooled server, the last generation of this server behind us, right, you remove all the fans, you do liquid cooling, your PUE comes down, all of a sudden it's 7 or 8 kilowatts a server, not 10. So this huge efficiency advantage.
30% power saving right away.
Yeah.
Easily. It's net saving. And to appreciate the customer, recognize and commit to liquid cooling. So indeed, we service our customer with very attractive cost.
Yeah.
So, because it's good for customer, good for ourselves, and good for our planet. So that's why Supermicro dedicated on liquid cooling so aggressively. And so,
and if the liquid cooling solution from Supermicro didn't exist, then those servers would be consuming 30% more power, right? And that's how much it'd be bad for the planet, it'd be bad for green, and maybe he would have 30% less GPUs even, right, in that facility because it's the efficient. He only can generate so much power. So there's all these things that tie together.
It's true. Lots of customers, even today, their power budget was limited. Their building, their city can offer them only 50 megawatt, only 100 megawatt, but they want to optimize their computing power. So that's why liquid cooling help there a lot, help up to 30% or even 40%.
Yeah, so they get the power savings, but also if they're
More
limited,
computing power.
if they're limited, they have more computing power. So
Yes.
this is very important, and the solution is difficult, right? So
Yes, that's why last year, although we deliver more than 50% of our product are liquid cooling, and we contribute more than 50% of liquid cooling in the world. But this year, the whole world liquid cooling percentage will be much higher because people want to save power, people want to save money and optimize their computing capacity.
but because you built the building blocks for liquid cooling early, you were able to show the world, and you were able to work with the customers to show the world that liquid cooling. You could do it last year. Now you're part of this ecosystem.
I'm very happy we can contribute a little bit to the industry.
Yeah. So now everyone's doing liquid cooling, right? Almost every NVIDIA server is going to be liquid cooled, right? There's still some air cooled, but most of them are liquid cooled. Whether it's GB200 or B200 or going forward, it's going to be mandatory even, not even an option. Right now it's still an option on B200, but
Today I would like to say majority will move to liquid cooling.
what and so now this isn't we talked about you going from motherboards to systems to now racks, right?
Yeah.
You don't one of the things that's challenging is that these accelerator ecosystems, because they have so many chips, right? You don't want to just do L6, right, which is what you were doing before, just the motherboard. You don't want to get to just L8, 9, 10, right? You started doing it with Hopper maybe earlier, L11, L12. Can you tell me about this?
Already L11 and L12.
With Hopper or before this?
About same time frame. It's parallel. And now maybe L13. Maybe L14. Coming soon.
Tell me about the building block of L11, L12. What are you doing, right? What is burn-in? What is, we talked a bit about burn-in, but what is this?
Okay.
Behind us is an entire rack. You're not shipping a server.
Okay,
right?
we are here. We are here for our customer, for our partner.
Yeah.
Right? So when customer, when data center need to build their data center quicker, when the customer had to build their data center with more reliable, better performance, also save money, we are here to service them. Recently, we announced data center building block solution. The idea is that Supermicro to build not just GPU, CPU, storage, computing power with rack, plug-and-play solution. But we also like to provide all the other key components for a data center. We build all of those components and well designed, validate, proof. So when we ship those parts to customer can quickly integrate and make their data center ready to run. And those components including CDU, liquid cooling CDU, CDM, water tower, dry tower, liquid to air heat exchanger, and chill door, including transformer, even including generator, and including the whole data center management tool, including cabling, deployment, and different level of service. Supermicro now is preparing all of those key components. So very soon, customer can just place an order to Supermicro, and then they can build their data center much quicker, much better performance, and much power saving, and save money. Save money, not just TCO, but also capital expense also saving, and easier for management. So the whole DCBBS is going on with very fast progress now. I believe within 6 months, Supermicro complete the data center building block solution will be all ready. And we like to service the data center in the world with our data center building block solution.
That's important to sort of think about, right? Is so beginning customer didn't want the motherboard; they wanted actually the chassis as well, and the cooling.
Yeah.
Then customer didn't want just that; they wanted the rack.
Yeah.
And so Supermicro, especially with Hopper, this is a very big advantage for why you were able to sell so many Hopper GPU systems.
Yes.
Was you would build the rack and you would do L11, L12, right? You wouldn't ship the server; you'd ship the rack with, and you'd burn it in, right? That's what's going on in the room next door. Is these servers are just running for hours and hours and hours and days, changing workloads, temperatures, and now that sort of extends to liquid cooling, right? And the systems behind us, it's not just the rack. In fact, you have the CDU there.
Yeah.
So actually, you just bring the bring the water pipes into the systems. Yeah. All the servers are actually already connected to the CDU.
Yeah.
So tell me about that building block, the CDU building block. It's very important. And Supermicro does a lot on their own there.
Yeah. Again, we provided a rack scale plug and play for 3 to 4 years already, and now is to further service customer by the whole data center building block solution. Maybe we can call data center plug and play very soon. And after we ship all the components to customer, we can help customer integrate the whole data center and make their data center quick, time to online, and with the optimization for schedule. Traditionally, people build a data center, say, need 2 years. Now, with our data center building block solution, we hope we can save customer half of the time and more reliable, more optimized in performance, and at the same time consume less power. Right? We mentioned about less power many times, and also make the system, the whole data center, easier for management, easier for service.
So let's think about that, right? So with if you just ship them servers, then they have to do the burn-in on site. So you do the burn-in here. If you ship them the CDU separately, then they have to figure out how to plug it together, test it for leaks. No, it's already done here. How does that then go to? Let's take this rack, ship it to the customer. You've been doing that for a few years. What is the mechanism? What is Supermicro doing, right? With the facility level equipment, because I don't think most customers or most people know what Supermicro is trying to do on the facility level. Well, they know Supermicro will ship me a rack that's tested. Great, but I still have to wire all my racks together. Yeah. I still have to test the cluster together. I still have to do the facility water. I still have to do the facility power. Tell me, what is Supermicro doing on facility cooling, facility power?
Okay, I mean, rack scale building block solution help customer save lots of time, lots of effort, and with optimized rack. Same thing, data center optimized building block solution will help customer better data center, quick time to operation, time to online, and save money and optimize your performance.
But what are you doing? I want you to say like what are the building blocks, right?
Okay.
Everyone
Because
understands rack.
Everything was designed, validate, test before we ship to customer. So after we ship to customer, we make sure customer just put them together, and it will work. That's why we are able to save customer, I believe, up to 50% of the time. Instead of 2 years to change it to 1 year. Instead of 6 months, change it to 3 months. So it's not just quicker, but better and save money.
And what are the building block solutions outside of the rack? What are you providing the customer there? What are the modules that are you're
That's
testing?
why I just mentioned, for example, in-rack CDU, they are Indo CDU.
In end of row CDU?
Indo CDU. That means one CDU support 10 rack or 20 rack. Right?
Yeah.
And kind of like a water tower.
Yeah.
And kind of like a dry tower.
You provide the water tower. You're
Yes.
trying to provide the water tower and dry tower that
we
goes
already
outside
provide.
of the data center.
We already provide a water tower. And dry tower is coming.
For chilling the water, the facility level water.
And chiller, yes. Including water chiller.
Yeah.
And including power module, power shell.
What kind of power modules and shells?
Plug and play power module, right? And then also BBU, battery backup unit, kind of to replace traditional UPS. So it's kind of better and cheaper and smaller.
So Supermicro has tons of experience inside the data center, but some of these parts are going outside the building, and they're being installed in different ways. How are you? Every site is different. All the regulations are different. Some sites, maybe I can't do a water tower because they're going to use water, and I'm in Arizona, and they don't have too much water, so they use dry tower.
We have dry tower. Yeah.
Yeah. So how do you work with the engineer to design their solution, or with the data center, with the customer, because maybe they know they need AI infrastructure.
Yes, there are lots of tedious job, but luckily it's a very interesting job as well. So we, as an engineering company, we work with partner, our vendor and our customer, and make sure all the modules are carefully designed and carefully optimized, carefully validated. And that's why after we ship to customer or with our contract, they can integrate it together quickly and make the whole data center, the whole cloud ready to run their application quickly.
So in the past, companies would buy just racks, right? They'd decide how many racks. They'd figure out their own networking solutions. They'd figure out their own cooling, everything. Today, there's hundreds of new customers, new companies who are trying to build data centers.
Yes.
And Supermicro is trying to
make their job easier.
Yes.
And not just make their job easier, but better. And also save money.
And faster.
And faster.
Yeah. That's incredible.
That's why I feel finally, as a Silicon Valley-based company, we are a very lucky company. I'm very lucky we select Silicon Valley as our headquarters.
So, Charles, you've mostly been talking about hardware building blocks. The hardest thing for customers is software, right? And it's why NVIDIA is such a valuable company. Yes, their hardware and their engineering on hardware is amazing, but their software is amazing too. Only providing hardware is one thing, but what are you doing to help companies manage their solutions?
Okay, very good question. Yeah, we have been working with customers for 32 years. We understand where the customer's pain point. And that's why we start to develop our software, management software, firmware, since 20 years ago. And today we have 1,000 engineers fully dedicated on optimize our management tool, so that when we deliver all the components to customer, the computing rack, the CDU, the water tower, the water pipe, power shelf, how can we help customer integrate all of them and manage all of those equipment, maintenance all our equipment easily, reliably, and at a lowest cost. So Supermicro, we introduced our data center management software and start to offer now. Indeed, we already deploy our management software, data center end-to-end management software to couple of customers. And so far, the response has been very good. So we are ready to broadly promote our management tool to many more customers.
I think that's really important to think about, because today, if a GPU system, you run a job, it turns off, the power swings up and down, and people have had problems where their data center wasn't ready and something stopped working. They don't know, is it the chip? No, the chip's actually fine. Is it the rack? No, the rack's actually fine. Is it the battery backup unit? Actually, that was fine too. It was something along the chain broke, but what was it? And I don't know, and I can't tell what the problem is unless I'm looking at everything holistically. And the only person who can look at it holistically is the data center, right? They're the only ones who know the building level cooling, the building level chillers, as well as the chip level. They're the only ones who has access to everything. So they have to have the software that ties everything together.
Yeah.
Or the same with cooling, right? Oh no, my chips are overheating, the performance is down. Is it because of the CDU? No, it might not be because of the CDU. Is it because of the pump on the rack or a pump in the CDU? No.
Yeah.
Is it because there's a leakage somewhere? No. Is it because the facility chiller's not chilling it low enough? No, I don't know, right? How do all their customer knows is the chip performance is down.
Yeah.
But why? And that's what this software, I think, has to do, right?
That's why our data center end-to-end software available now. We call SCC, Supermicro Cloud Composer. And the goal is to help customer easily to manage all the equipment inside their data center and outside their data center. And that product has been deployed in a couple of customers in the last few quarters. And now customer response has been great. And that's why we try to service many more customers. And because everything was designed by Supermicro and our partner. So it's guaranteed performance was optimized, quality was optimized, and cost was optimized. And when customer single stop shop with Supermicro, and customer got all the devices they need for their data center. So I believe this will be a big help to IT industry, to AI boom industry.
And with how much AI is booming, right? There's so many new companies. It's hard to find the talent to do everything for yourself.
Yes.
And it's hard to be able to afford that. So
that's why we are here to help.
Yes. And in the old days, it was, your tech might come and replace SSD when it's broken, but now it's more about, I know I need AI, I know I need to service my customer. How can I buy everything I need without having to hire hundreds of engineers for each data center or each company?
The answer is easy, Supermicro. So that's exactly the mission we try to achieve, kind of build all the components.
For customers to get time to market,
for
performance, and cost.
Yes.
So with storage, the industry has gone through a lot of shakeups, right?
Yeah.
Previously, you would buy a chassis with software from one vendor, Dell EMC or what have you will make a storage solution for you. But now it's much more vibrant ecosystem.
Yeah.
Because storage servers, there's software-defined storage.
More flexible choice for
There's
customer.
Much more flexible choice for the customer. You have a lot of storage platforms. Can you tell me a bit about those current storage platforms?
Okay, it's another big product line, right? We have, I guess, at least 30 to 50 different storage platforms. And most of those platforms have been co-work with our software partner. We work with 6 to 7 very well-known, good quality software company, and make sure all the software are installed here, validated here. So when customer buy our hardware storage, and in those cases we bundle with software as well, and then customer just power on and run, or kind of install their own software with our validation, and ready to run. So with this, I mean, we have more and more happy customers. They have their own choice, which platform, which software. They have
So if
free choice.
if a customer wants, a certain speed, performance, or Weka or whatever software they want, they can take, and you'll install it for them on the server too.
Yeah, we offer that option. Either we install everything and ship in rack, plug and play to them, or they can buy our system and install software by themselves. For sure, we prefer we integrate everything so that when customer receive the rack, it's ready to run and make sure it's 100% bug-free, compatibility gap-free.
So if a new customer comes along and they have significant orders to place, it's Supermicro will be ready, and you're preparing the company in capacity and in capital in every way to be able to service the customer.
Yes, finally, we are getting to be a big company, able to service many more customers. Not really large yet, but much bigger than before ever.
You always have the mentality that Supermicro is a small company. When will you admit it's a big company?
There are so many $1 trillion company now, right?
So Supermicro is still a small company.
I mean,
very humble.
Be humble is to keep the possibility to grow and to encourage our people to grow. Hey, there are lots of room to grow. In reality, yes, there are lots of room to grow.
Well, Charles, thank you so much for your time today. There's some vision that you have, and to make the world a green computing place. Have significant transformation for the world through AI, and your company is a part of that. Transformation for human society. So I'm excited to see what Supermicro does next.
Thank you so much for the interview and for the chance for me to share with our vision, with what we prepare for the industry. Yes, green computing should be everywhere, deserve to be everywhere. And today, luckily, we have a green solution, not just for computing device, rack scale, but data center scale, and data center hardware and software, complete management, turnkey solution. So I feel we are a very lucky company, and we like to share the luck with more customers around the world. Thank you for this opportunity.
Thank you.